This is the edge of the Hermit's Peak Calf Canyon wildfire. As big as this burned area looks, it's a small part of the entire acreage that went up in flames 3 years ago. Getting it to look like a forest again is going to require human intervention, which is why so much research is being done in New Mexico about how to make the most of a very limited supply of seeds and seedlings and people to replant trees.
There are two options, right? Once we leave the forest regenerate on its own. The second one would be reforestation. Problem with leaving the forest regrow, the ecological succession would take over, and we would get this forest that we all appreciate within the next 300 to 400 years. So it takes a long time to grow a mature forest that provides the services that we all enjoy, things like clean water, hiking areas, timber, firewood, hunting, fishing, any of those things that we enjoy. So that is not an option for us. We need to plant seedlings and try to restore the forest as it was, or similarly.
If we're reforesting a landscape like this, first of all, we need seed. And that seed is hard to get. That normally involves teams of people who go and scout ponderosa pine trees within the same kind of area, finding them when the cones are still green, picking those cones by climbing trees, drying those cones, extracting that seed, and then those seeds go to a place like the John T. Harrington Forest Research Center in Mora, are grown into seedlings which are typically 1 season old, then given to a planting crew who go out and plant large landscapes like this.
For reforestation, after such a large-scale fire, we cannot be reactive. We need to prepare ahead of time and collect those seeds and have them ready for whenever a fire might happen. So once we have those seed sources from the locally adapted trees, then we can grow those seedlings in the nurseries. And that's where the second step comes, which is growing the highest quality of seedlings that we can.
There's bottlenecks at each of those connections, and seed source which are climatically suitable for environments like this are quite hard to come by. But also, without the shade of the surviving trees, it's a much hotter and drier environment in big burn scars like this than it would be if there were some surviving trees. So those seedlings need to be particularly hardy and be able to cope with a lot of different climate extremes. If that's from real cold snaps like we see here at high elevations, or very dry periods like we see in areas like the Las Conchas burn area.
The JTH Forestry Research Center is quite unique because we have a tight relationship between the research that we do and the production line. So we can apply what we learn immediately. My job there is to study stress resistance mechanisms in seedlings, and more importantly, how to implement that in the nursery so that seedlings come to the field prepared to deal with those high temperature, drought, and cold. So we're talking about root development, for example. We're trying to promote early and fast root growth, which will increase their chance of survival. We are also trying to grow seedlings that have a higher percentage of root mass. So when they're exposed to sunlight, they do not demand so much water. They don't get dry, basically, because of so much leaf area. There are many other physiological mechanisms that seedlings develop, and what we try is to have them develop those mechanisms early on in the nursery, so they do not have to do that in the field.
What kind of seedling survival rate do we see when we try to replant after some of these big wildfires?
Half of our problem that we have in the Southwest with our reforestation effort is those seedling survival rates are really variable and site dependent. A 2015 study which looked at multiple planting sites after a high severity burns had an average seedling survival of 25%. In some of those areas they saw survival of 70%, some they saw none, and that average is like a real mix. So figuring out what elements within those sites govern that seedling survival can help us learn and applied the lessons that we learned from those different sites to different areas and hopefully increase the seedling survival rates in all reforestation areas.
And this is microclimate. So
This is microclimates.
what
yeah.
is microclimate?
So microclimates are places on the landscape which are either hotter or cooler than the prevailing climate. And that may be based on topography, north or south-facing slopes which receive more solar radiation or sunlight typically over the period of a year, or areas which funnel water down little valleys and they're wetter and cooler than other areas. So being able to identify those microclimates, those little microsites, can be really beneficial for reforestation efforts. So we can plant on those north-facing slopes and in those little gullies which are wetter and cooler. So when we plant seedlings, we typically put them in a Vexar tube, which is this plastic bit of netting, which is biodegradable. And it's just to protect it from browse, being eaten by deer or elk, just to give it a chance before it forms some woody mass and is protected from that. So this is our little seedling. He's only about 6 months old. And he would have come pretty much straight from the greenhouse around this kind of size, so he hasn't had much time to grow yet. But what we did develop to measure the variables which might predict the survival or growth of this seedling is these microclimate data loggers that we made at UNM, which measure soil moisture, air temperature, and humidity and light levels at the same sort of scale that our seedlings planted at. So using lots of microclimate data loggers and drone imagery, we can model those microclimates over a site and then identify before planting where we're going to see probably the most seedling survival and highest growth. Equally distributing our reforestation resources over that entire burn area is not likely to lead to good results. We're probably better off targeting those areas of high seedling probability and planting in those. Here in this Gamble Oak patch, there's a lot of leaf matter which retains a lot of soil moisture, and we can see if we dig this up, there's a lot of moisture in the soil in patches like this. So this creates its own microclimate, its own little microsite, which is more favorable to the planted seedlings, retaining that moisture, buffering against solar radiation, and allowing them to grow a lot faster and survive a lot better. As we can see from this seedling, who looks pretty happy here in this little Gamble Oak patch. In 10 to 12 years, those seedlings that we plant will produce their own seed, and then we can fill in the gaps between those patches of high seedling survival probability, as opposed to trying to blanket the area in seedlings and spending a lot of money and a lot of time chasing the same kind of tree density that was there previously and trying to replace that within one generation. One of the main driving factors that we see in high severity burns like this one is really high density of trees. So typically if we were to look at the Gila wilderness down south, which is a naturally fire maintained ponderosa pine system, the trees are much sparser in their density, and there's areas without any trees within them. So when a fire does start, it generally burns at low severity. But when we have high densities of trees like this, and a fire like the Hermit's Peak Calf Canyon burns, it will burn at high severity, travel very quickly, and be crown fire, which is jumping from each tree canopy to the next. All of the trees which would produce seed for the forest to naturally regenerate are now dead.
The forest that comes back is probably not going to look like that carpet of trees that we knew before the fires. What might it look like instead?
Well, hopefully what it will look like is a mosaic forest. We will have a mature forest, maybe in about 100 years or so. But also we want basically a heterogeneous forest, patches where that have recently burned at a small scale, low intensity. Those will support certain wildlife, certain services for the communities down the slope, down the drainage, and areas where we will have seed sources, so that forest expands into places where we cannot access or perhaps were not planted for any reason. So ideally, we want the forest dynamic to come back to a natural regime where parts burn but at a lower intensity, and that creates a very heterogeneous forest